Welcome to Gravity Fields Festival Online and to this very special event, this talk by Marcus de Sautoy. My name is Simon Hollingworth and I'm the creative producer of Gravity Fields Festival, or would have been under different circumstances. I'm part of the team, the South Kesteven District Council team that runs the art centres and the festivals here. And well, we all know 2020 has been an unusual year, and as I
Welcome
here,
to Gravity Fields Festival Online and to this
here,
very special event
in the Guildhall Arts Centre. I'm normally looking out this window at this time on the Saturday night of Gravity Fields. There, of course, would be all sorts going on. The roads would be closed. There'd be people everywhere. But of course, we know that's not happening. But we are delighted that we've been able to pull together a special day today. We've had an online Gravity Fields, a little flavour of the festival that we've enjoyed sharing. We've had all sorts of things today, lots of stuff for children and families, and it's been really great. We're really chuffed that everyone's been taking part and that we've been able to do this in a small way, but just to keep the flavour and the spirit of the festival alive. Tonight, of course, is our headline event, and we're really delighted to welcome Marcus de Sautoy to give us a live talk, which is not able to be caught up again afterwards. So if you're watching this live, this is it. This is your one chance. We're delighted to welcome Marcus with us. Marcus, as I'm sure anybody watching will know, is a mathematician, a science communicator, author and fellow of the Royal Society. He's also the Simonyi Professor, I knew I'd get that wrong, Simonyi Professor for the Public Understanding of Science and Professor of Mathematics at Oxford University. And of course, some of you will know Marcus joined us at Gravity Fields Festival in 2016 with his talk, What We Cannot Know. Tonight, Marcus will be talking to us about the creativity code and explaining how AI is learning to write, paint, and think. Over to you, Marcus.
Well, it's wonderful to be with you, if just virtually, and let me assure you that I'm not an avatar, a piece of AI giving this talk. It's really a human coming to you through the screen, although perhaps you will have to judge that by the end, a Turing test for you. I'm going to be talking about artificial intelligence and the impact of this new technology on society today. And I'm going to take a little bit of a risk and use a little bit of technology in this talk. I'd love to get some sort of interaction with you out there. One of the frustrating things about this is having to pretend there's an audience there, imagine the audience, but hopefully you're all out there. But I'm going to use a little bit of technology to get you to interact with the presentation. And to do that, all you have to do is to perhaps get your mobile phone out or another window. And if you put the following address into a browser, it's a piece of software I'm using called Glissa. So glsr.live/creativity code, then you'll be able to see some of the slides that I'm going to be presenting with, but most importantly, to vote on a few things I'm going to quiz you with. I'm going to give you a few Turing tests to see whether you can sniff out a piece of art that's been created by a human versus artificial intelligence. Is there something which gives the AI away? So, and we'll be able to look at the data and the votes that you're making using this piece of software. So try and log on to that site if you can. Don't worry if you can't. It won't hopefully upset your enjoyment of what I'm going to present to you. There's also the opportunity to ask some questions through this site. And towards the end, I'm going to talk for about 45 minutes. And then I'll look at a few of the questions that hopefully some of you have been posting on the Glissa site. And we'll look at some of those. And I think even you can vote for questions that you think are particularly good. So hopefully good questions will come to the top. So it's interesting because as a mathematician, I think a lot of people think that my job should be one that's already gone, that a computer should be able to do maths, shouldn't they? Because isn't a computer, artificial intelligence, really just very logical, and being able to do mathematics should be something very possible for a computer. But I actually use this word creativity as my kind of protective shield against why I think computers couldn't do mathematics, because I believe doing mathematics, doing science requires a lot of imagination and creativity. If you think the breakthroughs that Newton made that we're sort of celebrating in the Gravity Fields Festival, absolutely extraordinary during the pandemic that he went through. He retired from Cambridge up to Walsall Manor, came up with most extraordinary new ways to look at the world, the idea of the calculus. How could a machine ever come up with such original ideas? Well, I certainly used to think that was the case, but a few years ago, I saw a story which has kind of changed my mind, and I saw the example, what I think perhaps is the first example of creativity made by a piece of code. And this was actually in the context of a game that traditionally AI has found very difficult to play. We know that computers have been able to play chess. In the 90s, they beat Garry Kasparov, the best the humans could muster at this game. But the ancient Chinese game of Go is a game that traditionally computer scientists have found very hard to code. So this is a game that's played on a 19 by 19 grid, and hopefully you're seeing a picture of two humans seemingly playing this game. And you put black and white stones down on the board, and the aim is to try and surround more of your opponent's territory than they have of yours. And if you ask a Go player, here on the right, you see Lee Sedol, a Korean player, one of the world's best players. Go players find it very hard to actually articulate why they're making moves. And so to actually write code in the past, where you had to write, if this, then do that, you had to sort of understand how you were playing in order to write code. So when a company, DeepMind in London, said, well, we think we've got a bit of code that can challenge the world's best, Lee Sedol was completely dismissive and said, well, look, I'll be able to beat this piece of code easily. And they arranged this match 2016 to play a match of 5 games against this piece of code. So actually the person on the left you see in this picture, human, is actually playing the moves that the code is suggesting. Weirdly, we still haven't made robots good enough to pick up these very delicate little stones and put them on the board. So we still needed a human to actually put the stones on the board. But the moves were being made by a computer. Lee Sedol was completely dismissive, said, I'll be able to beat this thing 5-0. He was greatly shocked to come out the other side of this match, having lost 4-1. And the one game that he did win, he regards as the most valuable of his whole career. So perhaps not surprising that we're seeing computers, code, doing things better than humans. We've sort of got used to chess, so why not Go? I think for me, what was the exciting thing about this match was there was a moment in game 2 when something really extraordinary happened. It wasn't just that the Go was playing the game well. I believe it did something truly creative. This happened in the second game, and I'll show you the board as it was at that point. So let me show you the board. So what had happened is Lee Sedol had made his 36th move. He was playing whites, and he went to the top of the hotel in Seoul where they were playing the game to smoke a cigarette. We humans still need nicotine for our to boost our creative ideas. And then AlphaGo suggested to put a black stone down on the 5th row in from the edge. And you can see I've put a little white circle on the black stone. Now, I was watching these matches obsessively on YouTube because I thought, well, I've always thought this game is rather like doing mathematics. And if a computer could play Go, maybe it could do maths. And I remember all the commentators gasping when AlphaGo made this move, because traditionally to play this deep into the board early on in the game is a very weak move. Your Go master teaches you can see the stones that have been laid up to this point. They're all on the sort of 4 rows in from the edge. 5 rows in, it's considered a weak move. So the commentator said, oh, wow, AlphaGo is going to lose the match from this point on. What a weak move. Lisa Doll comes down, sees this black stone on the 5th row in, very surprised. Seems a really weak move in his mind too, but he's a little bit more suspicious. He's already lost the first game. As he thinks for a while, he just can't see why it's made such a weak move. The game goes on, and a competition begins to build up for territory, sort of growing from the bottom right-hand corner of the board. And it turns out that that black stone laid down in move 37 is the key move which controls all of this territory. And it wins this large swathe of territory for AlphaGo and ultimately wins AlphaGo the game. Now, for me, this move passes 3 things I'm looking for if I'm going to call something creative. And this is actually something that I learnt from Margaret Bowden. She's a cognitive scientist, and she has a rather nice definition of creativity, which I thought we'd use during the course of this presentation. So she said, you should regard something as creative if it's new, if it's surprising, and it has value. Now, for me, the thing about this move was certainly a new sort of move, but it passed those other 2 tests. Surprising. Yes, it was surprising because the commentators, they all gasped. It was a very unusual move. What they thought was a really weak move at that point. But ultimately, by the end of the game, AlphaGo proved that this move actually had value because it won AlphaGo the game. And I think the most exciting thing is the way this code was produced, because the code isn't being written in a traditional top-down manner where you write instructions to for how the code is going to play the game. The code actually learned to play the game through interaction with games that humans had played by playing itself. So the code was allowed to sort of grow in a sort of bottom-up manner, something we call today machine learning or deep learning. And the idea is that the code can change and mutate as it learns and gets things wrong. It updates itself and says, well, I've learned from that failure. If I did this next time, then maybe I would be able to win the game. So the code grew and changed and developed and became something different from what the original humans had written. And actually, if any human had seen this line of code which said, oh, play early on the 5th row in from the edge, probably a human would have deleted that code saying, well, that's a very weak move. So this line of code really emerged out of the learning process of the code. So I really think it deserves to be called a creative move for the code rather than the human who actually coded the thing in the first place, because that line of code emerged out of the learning process as it interacted with data and played games against itself and gradually got better and better. And I think the most exciting thing for me is that that we sort of, this piece of code has taught us how to play this game in a new way. Now we've sort of learned a new way to play the game. So I've got this rather nice image that I had in my mind when I saw this move, and I'll let me share this with you. So it's as if we'd sort of reached what we thought. You know, Lisa Doll thought he'd reached the peak of how to play this game. But AlphaGo showed us that actually there's an even superior way to play the game, that sort of cleared the fog around us and showed us that there was a new way to do things. And I think for me, that's what's so exciting about this new technology, that it might actually help us as humans to see new ways to do things. I think as humans, we often get stuck in kind of very machine-like ways of thinking. I know in my own work as a mathematician, I will perhaps repeat things that were successful in the past, hope they're going to be successful again. And sometimes I need a push to break me out of my rather mechanistic way of thinking. And I think this is the powerful opportunity that we have with this new sort of AI, that it might actually help us to be more creative as humans by showing us new ways to do things. So when I saw this moment, I really thought this was a phase change in artificial intelligence. And it set me off on a journey which culminated in the writing of a new book, The Creativity Code. And actually, there's a link on the Gravity Fields website, little plug to if you'd like to get a copy of the book. And I wondered if AI can be creative in this very restricted realm of a game. It's just black and white pixels on a board. Where else could it be creative? Could it be creative in the world of art or music or literature or mathematics or science? So the book is a kind of journey to see how creative really can this new technology be. And it's very interesting that one of the very first coders in history was already thinking about the possibility of code actually being creative in the arts. We celebrate Ada Lovelace as the first computer coder, and she used to be taken along by her mother to see the great scientific experiments of the day. And there was one time she was taken to see Charles Babbage's analytic engine, and she was this was a machine created to speed up multiplication, long division, square roots, and things like that. But Lovelace realized, well, actually, you might be able to get this machine to do more interesting things. And she started to write instructions to make it do some more interesting things. And we now regard those instructions as the first examples of computer code. And in the notes that she wrote, where she put some of these instructions down, she writes, the engine might compose elaborate and scientific pieces of music of any degree of complexity or extent. So she's already thinking about the idea that code might do something more interesting than just multiplication. It might actually be able to write music. But she has a word of caution about the creativity of the code. She says, it's desirable to guard against the possibility of exaggerated ideas that might arise as the powers of the analytic engine. It has pretensions, no pretensions whatever, to originate anything. It can do whatever we order it to perform. And I think in the past, I would have agreed with that, because code in the past was written in a very top-down manner. So if a piece of code actually created some music, you really should credit the human as the creator, the composer, because they wrote the instructions and the machine just implemented them. But I think this has fundamentally changed with this new technology, because if the code is actually mutating, changing, becoming something new, it's actually putting some distance between the original human and the code that emerges out of this learning process. And so I think we're really, anything that music might we might need to credit the actual code itself rather than the original human who wrote the code from which it started to learn. So there's now actually, people have probably heard of the Turing test. I mentioned it at the beginning. Are you sure that I'm really human in an interaction online? Can you tell the difference between a human and a piece of code pretending to be a human? So there's actually a new test out there, something called the Lovelace test. So the idea of the Lovelace test is that, could a machine actually create a piece of work, a creative work of art, such that the process is repeatable? So this is important because we don't want the code just to be randomly producing things. The code should, the art should be a product of the actual code itself, not something external or a hardware error. But here's the test. That the programmer originally programmed the thing is unable to explain how the algorithm produced its output. So this is the kind of challenge that if something will pass the Lovelace test, we need to really call the product the creativity of the code rather than the coder. So how well has AI been doing at things like music or writing a novel or the visual arts? Well, I'm going to start with the visual arts because that's where machine learning has probably been most successful. In the past, artificial intelligence used to have real problems with recognizing what was in an image. Somehow our brains have developed over long periods of evolution to be able to detect very quickly what is in an image. It's helped us to survive, to be able to recognize an animal in the jungle, for example. But AI had a lot of difficulty understanding all of these pixels and integrating them into some idea of what is the picture a picture of. But machine learning has allowed code to be given lots of examples of pictures. Here's a cat, this one's a dog, and starts to build up a sort of bank of questions that helps it to distinguish from its learning when it's given a new image to know what animal it's looking at. So the visual realm machine learning has been incredibly successful. And so if AI can recognize visuals, can it make its own visuals? So any artist really starts with learning the art of the past, learning about styles of great artists in the past, and AI has done the same thing. So it started with the art of the past to try and understand what makes it special, and can I reproduce something of a similar quality? So here's your first kind of little test. I'm going to give you two images that one is produced by a human artist, and the other is produced by a piece of AI. So here are the two images. Now, if you look at those images, you'll probably be able to tell who the human artist is, because he has a very particular style. This is Rembrandt. But which of these is Rembrandt? So what you can do if you're able to get online to glisser.live/creativity code is that you should now have the opportunity to do a little vote. So what I want you to do is to press on the image that you think is the AI image, which one doesn't give you the Rembrandt shudder. And if you could, then you should be able to submit that to me. And hopefully we'll be gathering lots of data. It'll come down to me sitting here in my office. And let's see. So hopefully you're doing some votes, and we'll see whether. So here are the two images. And let's see whether, wow, so there we go. So hopefully you're seeing the data. It's pretty split, actually, 55-45. That's almost, wow, 50-50. There you are. It's kind of Brexit vote. You really don't know which one is which. So the moment's a slight leaning for the portrait on the left being the AI one. That's interesting. The portrait on the left looks a bit kind of cleaner, a bit more photographic. Is that perhaps what's giving you the leaning towards the one on the left? But still quite a lot of people thinking the one on the right is the AI one. So let me reveal the answer. Yeah, it was indeed the portrait on the left. The moment you're doing pretty well as an audience picking that up. The portrait on the left has a quite photographic quality. Now, in some ways, I had to try and find a Rembrandt that you wouldn't immediately recognize. So I think the portrait on the right, which is by Rembrandt, is actually rather a shit Rembrandt. Oh, sorry, I probably shouldn't say. A rather bad Rembrandt. And so, you know, it's a bit fuzzy, not his best work. But I think the portrait on the left has done pretty well at picking up Rembrandt's style, and obviously convinced a good proportion of you that that was the original. But you might say, well, what's the point of making more Rembrandt? We've got great Rembrandts. Isn't that sort of pastiche? A lot of people were very critical. One of my favorite art critics is Jonathan Jones. Here's what he wrote about it. He said, "What a horrible, tasteless, insensitive, and soulless travesty of all that is creative in human nature, when technology is used for things it should never be used for." But frankly, anyone who wears a shirt like that, I slightly mistrust as an art critic. But there you go. But I suppose Jonathan Jones has a point, because, you know, Rembrandt's great. We don't need more Rembrandt. But on the other hand, one of the fascinating things is that AI can take data of the past and actually reveal new things in that data. So I don't think in the case of Rembrandt, but for example, Jackson Pollock, a kind of algorithmic approach has revealed that Pollock's work has a very special quality to it that we hadn't realized before, that it's very fractal in quality. So I think there is a point in using AI perhaps to reveal new patterns, new insights into the data of the past. But for me, the exciting thing is to push into the new. How about AI not creating something we already recognize, but something genuinely new? So here's your next challenge. I've got some pieces of art that are 4 of them. Let me share these with you so you can see them. And again, this should be coming through to your phone, so you should have the chance to vote on these. So 4 of these paintings are done by a human, and 4 of these paintings are done by artificial intelligence. And again, hopefully you'll get these chance to vote. I will also vote as well. although of course I know what the answer is. So I shall, so which one's the AI ones? Is it the 4 on the left or the 4 on the right? So let's reveal what you're thinking about. Oh, wow, there you are, 50-50 again, really quite split. Although 33 to that might actually tell me how many people are actually able to vote, that we've got it exactly even 50-50 there. But so fluctuating away there, not too sure, but a little bit of an emphasis for paintings on the right, perhaps, being the AI ones. So let me show you those again. So the AI ones, perhaps you're thinking those on the right. It's interesting. They're sort of slightly more complex than the ones on the left. But let me reveal the answer to you. So which one is right? Yeah, so the ones on the right are actually the AI ones. Now, it's kind of interesting because these are actually shown at Basel Art Fair, and nobody was told that there were any computers involved. And people had said that asked afterwards that they had more of an emotional reaction to the AI paintings than the human paintings. And when they were told they were done by AI, there was, a lot of people felt cheated. I think this is an interesting reaction because, part of the point about art is that we want to connect with another human being, with another emotional world, and to then find that somehow your emotions have been stimulated by something artificial is very unsettling. But I think one has to remember that this AI has learnt on the art of the past. So it's learnt on our emotional world expressed through our art. So it's not surprising that if it produces something that through a learning process where it's been given emotional works of art, that it will produce something that might resonate with our human emotional world. But the other interesting thing is how these paintings were created, because this is a very interesting new algorithm called a generative adversarial network. It's actually 2 algorithms, almost like working in a game, in a competition between each other. One is tasked with creating new art. It learns the styles of the past and tries to create something which is genuinely new, breaks those styles. The other algorithm is a discriminator algorithm, and it's tasked with trying to say, oh no, it's too much like a style I've seen before. It's not new enough, or perhaps the art's just gone too far, so it doesn't look like art at all. It's just a mess. So by using these 2 processes of creator and discriminator, it is able to produce something which is kind of breaks the mold, is new, but isn't too new that we don't recognize it as something that we would regard as art. And for me, I think this is one of the interesting things, is this sort of captures something that a lot of creative artists talk about in their creative process, the idea of sort of 2 things competing against each other. This is Paul Valéry, poet, French poet. He said it takes 2 to invent anything. The one makes up combinations and the other one chooses. And I think a lot of creatives talk about this kind of idea of 2 things working against each other, this bubbly creative side and then the critic. And I certainly recognize that kind of in my own creative process. I often work along with other mathematicians, and I as a partner, and one of us is the creative bubbly one and the other one is the discriminator algorithm. So this algorithm that produced this art actually captures, I think, something very much about human creativity, these kind of 2 processes in the brain sort of competing against each other. But I think probably one of the most interesting stories of visual art that I came across on my journey writing this book actually produced art that wasn't particularly brilliant art. It's rather sort of kitsch looking art, but I think gets to the heart of why we humans make art. As I said, the humans that felt cheated when told these were pieces of art made by AI, you want to connect with another person's emotional world, the internal world of the other, which is very often deeply mysterious. But what we're beginning to find is that we're producing code which is making decisions, and we don't really know quite how the code is making its decisions. And we need to sort of probe the internal world of the code. So a very interesting example, Google has a very successful vision recognition software developed through machine learning. But Google were interested, well, actually, how is the code seeing the world? What is it actually seeing. It's able to recognize things, but can it tell us what it's actually seeing, how it's seeing? So what they did was they asked the AI they gave it a kind of picture with not very much in it, something random pixels or something with no clear identity, and then asked it to dial up what it saw in the picture. So, for example, it might be given an image like these jellyfish, not very clear, and then the AI was just asked to accentuate anything that it saw inside there. It's a little bit like playing that game where you look at the clouds in the sky and you try and pick out, well, that's a snake and that's a fish. What was the AI seeing? Well, when it did this strange image started to emerge, and it told us how the AI was learning, because you could see lots of eyes, lots of faces, lots of animals, mechanical things, and it helped us to understand how the AI had learned. But what was interesting, it also helped us to pick up bad learning, because when it was given a very sort of gray, pixelated picture, it started to see dumbbells emerging inside this picture. But when it sort of drew the dumbbells in the picture, it always attached arms to the dumbbells, because it had never seen a dumbbell which wasn't being held by a human. So it thought the dumbbell was an extension of our anatomy. So I think this is very interesting, because we can actually pick up bad learning. And this is one of the things with this new technology, that there are biases that are beginning to emerge because of biased data in, biased algorithm out. And I think that I rather like this quote of Paul Klee. It really gets to the heart of what art is about. It's not about reproducing the visible. We can see that. It makes things visible. And this art, this rather kitsch art called Deep Dream that Google developed, helps us to make visible what's happening inside the code. And as Marshall McLuhan said, art is our distant early warning system that can always be relied on to tell the old culture what is beginning to happen to it. So the visual world, very interesting. I think there are a lot of successes, both in reproducing old style, pushing into the new, but also helping the visuals, helping us to understand the internal workings of the code. What about music then? Ada Lovelace offered that challenge of music. Well, there's quite a bit about music in the book. I'm a big fan of music, play a lot of musical instruments. There's one behind me. I have to do that. So a lot of stories of music, but let me just tell you one very interesting piece of AI that learned to play jazz. And it listened to the improvisations of a jazz musician called Bernard Lubat, and then started to learn the style and was able to play back in a kind of call and response mode with Bernard Lubat. It was Lubat's response that was interesting, because he said, well, it's playing like me. I recognize that world, but the things that it's playing, I've never thought of doing with my sound world. It's years ahead of me. Yet everything it's playing is definitely my kind of world. So I think here's another example of that kind of being pushed off what we thought was a peak of performance and revealing there are new ways to do things. And I think that's the exciting challenge we have, that AI can take our creativity of the moment and show us there are still new things that we can do with it. But I'm going to turn to the written word, because I'm talking about a book that I've written. How easy would it be for an AI to write a book about AI? And it's interesting that I thought AI would be find writing reasonably easy, because there's a lot of data. Writing is a sort of code, so can't it learn that code? But where it has been successful is on very short form. So in fact, 350 words of my book was written by a piece of AI. And the challenge for you, if you get the book, is, can you identify that passage? I asked it to tell one of the stories, and sure enough, it was able to. And the rather frightening thing is that, not even my editor at Fourth Estate has been able to pick out which was the piece of text written by the AI, which I find slightly depressing, because I thought it was so obvious. I thought it was very bad, but maybe that's a reflection on my own writing. So it's very good at short form. So poetry is one place where AI is actually quite successful. And interestingly, one of the very first examples of code sort of writing text was a kind of actually love letters. So let me share this with you. This is a love letter actually written by one of the machines that Turing developed up in Manchester after the Second World War. So this is the Manchester Universal Computer, and they were rather surprised when it started leaving love letters around the lab. But actually, it had been written. It was an algorithm written by one of the team. It was a template, and they were actually using a random number generator that Turing had developed to randomly fill the template with words of love to produce these little letters. But poetry is a place where AI has been reasonably successful. So here's your next challenge. You can pick up your mobile phones, vote again. I've got a few challenges of poems that I want you to see whether you can decide which ones are human or not. So we're going to play bot or not. Can you tell which poems are written by piece of AI and which are written by a human? So here's your first challenge. I'll read the first 4 lines of this. Mortal my mate, bearing my rocker heart, warm beat with cold beat company. Shall I earlier or you fail at our force and lie the ruins of rifled once a world of art? Okay, so over to you. So now you get the chance to vote. Press the bot icon if you think that was created by a piece of AI, or press the not if you think it was actually by a human. So I shall do a little vote as well. Of course, I know the answer. Do you think that was a bot or not? So let's reveal what you're thinking of. Hopefully there are people some voting out there on a Saturday evening, wild Saturday evening here in the UK. So let's see what you're thinking. Okay, so about a 2-to-1 splits that is by a piece of AI. So okay, well, I've got 3 poems for you. So what I will reveal in a minute whether it's moving more and more, 73% for being by an AI. Okay, so are you ready for your next poem? So here's your next one. Now, this one's actually quite hard to even read, but I'm going to send you the vote so you can start voting. But so here we go. There are smallnesses of plasticide reaction of real time, of packs, of displaced exclusionary heart, hurt, of powerlessness, of magazine fired, non-dignified, as head fatty implied, internalized violenced, of frozen helplessnesses of off-white. Okay, so what do you think? Do you think that's AI or is that human? So how much am I messing with you? Because that clearly looked like a bit of code, but then it probably too obviously by a piece of AI to really be by AI. But maybe I'm double bluffing you, triple bluffing you. So what do you think? Right. So again, a bit of a majority going for that being actually code. It looks like code and it probably was code. Okay, so some votes there. Although it's tilting a little bit towards, a bit more of you thinking that probably could well be a human. There you are. It's gone 50-50. Maybe I'm leading you too much. All right, your third. Here's your third. Just went majority for. Okay, what about this one? So we had robot, and then let's say you majority by the end thought the second one was human. So here's your third one. Imagine now the dark smoke, awakened to fly all these years to another day. Notions of tangled trees, the other side of water. I see it is already here. Sequences of her face. See it is shared, and old friends pass their dreams. Okay, so over to you. There's your vote. Hopefully that's coming up on your mobile phones, on your browser. Bot or not? Was that written by a piece of AI or by a human? Now it's very interesting because there is, of course, a little bit of delay on YouTube. So although I'm sitting here saying voting, I need to give you a little bit of time because you're actually getting this, I think, 30 seconds later or something. So yes, interesting sort of mixing of timescales here. So hopefully we will have got some votes coming in. Oh, okay. So majority this time going for the robot being the last one. Okay, so we went robot, bit of an edge for human, and then robot. So let me reveal the answers. Well, I'm afraid poor old Gerald Manley Hopkins is going to be turning in his grave that you all thought that first poem was majority by an AI. It was in fact by Gerald Manley Hopkins, although I chose Hopkins because I've never really understood any poem that he's ever written. It seemed to be, I don't know what he was doing when he was writing that poem, but anyway, so the first one by a human. The second one is also by a human. This is a young Australian poet, Mes Breeze, who's very interested in the interaction of code and humans, that code has a kind of poetry to it. So that means the last one surely has to be the AI. This is actually the cybernetic poet, created by Ray Kurzweil, was very famous for talking about the singularity. And he gave the AI a lot of Victorian poetry to learn on. So poetry, not too bad. We saw we were able to trick you a little bit. But what about more sort of long form prose? And this is actually very interesting, because I really saw that AI is having a lot of difficulty with kind of things that have a temporal element to it. So for example, it can produce amazing texts, and some of you may have seen an article written by a piece of AI produced by OpenAI in The Guardian recently, and it's able to produce pretty coherent text on a sort of short form. But what it has trouble with is sort of long form narrative. So it can't really go beyond something of about 500 words. But there was a team in America, a team of artists and coders, who were quite keen to try and push it. So they were big Harry Potter fans, and they were very disappointed there were only 7 volumes of Harry Potter. So they thought, okay, well, why don't we get the AI to learn on all the works of J.K. Rowling and to produce us an 8th volume. So they did, and it actually started off quite well. So let me show you what the AI produced. Actually, I even like the title that the AI came up with: Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. What a great title for a new book. Anyway, it started off pretty well. Magic. It was something that Harry Potter thought was very good. Well, it's already picked out that magic is a major theme in these books. Harry Potter, the main character. Leathery sheets of rain lashed at Harry's ghost as he walked across the grounds towards the castle. Well, I think that's a lovely image. Leathery sheets of rain. I don't think I would have come up with such an interesting image for rain as leathery. But from this point on, it really began to lose the plot. Ron was standing there and doing a kind of frenzied tap dance. He saw Harry and immediately began to eat Hermione's family. Ron's Ron shirt was just as bad as Ron himself. So it looks like us writers don't have too much to worry about at the moment. And I think what's interesting is that this AI is very good at producing things locally. So, for example, the musician, the jazz improviser, the jazz continuator, it's called. It's very convincing to start with. You listen and it sounds, really quite convincing. But after about 5 minutes, it just becomes boring, because the AI doesn't really know where it's going. It hasn't got really anything to say other than being able to produce something that locally sounds quite okay. And it's the same with the text as well. It can produce quite coherent and interesting kind of ideas in the short form, but the long form, it really is finding it very challenging. And I think one of the things that came out towards the end of this book, actually, I decided to take a different definition of creativity, not the one that Margaret Bowden came up with, but creativity as defined by psychologist Carl Rogers, who said that actually creativity is our best tool for understanding our own internal inner worlds, our conscious worlds, and in particular, trying to understand somebody else's conscious world. And I think, I speculate in the book that I think maybe human consciousness and human creativity may have emerged about the same time. We see sort of creative acts like paintings on walls starting to appear 40,000 years ago, and that maybe our consciousness made a shift at that point. And I think that creativity was our tool for sort of examining this new thing that appeared inside our humans. So, one of the great scientific challenges of our day is the hard problem of consciousness, trying to understand when something might become conscious. What makes consciousness? Is your consciousness anything like mine? And I think that our art is perhaps our best kind of fMRI scanner for trying to understand these internal worlds. And I rather like this quote that George Eliot came up with. she wrote that the greatest benefit we owe to the painter, or whether painter or poet or novelist, is the extension of our sympathies. Art is the nearest thing to life. It is a mode of amplifying experience and extending our contact with our fellow men beyond the bounds of our personal lot. So I think that at the moment, AI is a great tool for pushing our own creativity. It's helping us to behave less like machines, giving us new ideas, but and genuinely new things appearing. But I really think that, an important word that came up for me quite often was this word intention. The intention is still coming from the human. The AlphaGo didn't want to play that game of Go. It was the human that started the piece of code off playing the game. And I think until there is intention from the machine, that really the creative act is still coming pretty much motivated by the human. But I think there will come a point when AI does become conscious, and we're going to need tools to know that moment, because that's going to be another key phase change, I think well into the future, but I do think it will happen. I think in some ways, even today, code has got an internal world that has become so complex through this machine learning process that that it isn't able to articulate quite how it's making decisions. And I think that we need ways to kind of probe how this code is kind of thinking. We can't look at lines of code one by one. That doesn't give us any insight anymore. So already I think our art, as Marshall McLuhan said, it's it's our distant early warning system, helping us to understand what's happening in this new technology. But when AI does become conscious, which I think one day it will, I do think it'll be a very different sort of consciousness to human consciousness. And I actually love this quote, which I used towards the end of the book, from Wittgenstein. He said, "If a lion could speak, we could not understand him." And I think that the same is true of artificial intelligence, that it will be a very different sort of consciousness that will emerge. And we're going to need as many tools as we can get to understand what it might be like to be one day a piece of conscious AI. So I hope you enjoyed that kind of journey through some of the stories of this new book, The Creativity Code. A few questions appearing from the Glisser. So please add some more questions if you have them. Let me have a look and see what you've been asking. AI is becoming more important in business, such as helping financial institutions predict the future. Given the issues you have outlined, do you think this is sensible or not? Well, I do think that one of the challenges is how things are making its decisions. So I think, perhaps not take business, but take medicine, for example, which is one of the places that AI is, making big strides, taking, for example, a lot of medical data of drugs that we've produced so far, and making suggestions for new drugs. There have been some very interesting examples of antibiotics, for example. Antibiotic resistance is one of the big challenges for science, coming up with, and there are things which are resisting these antibodies. So we need to come up with new ones. And machine learning has managed to develop some new drugs that have turned out to be very successful when they've been put into medical trials. But if an AI makes a suggestion for something really crazy, maybe it's that move 37 in the game of Go. How much can we trust the AI when it's not just a game, but say in a medical setting, or it's suggesting an investment which looks traditionally very weak, yet has it seen something new? So I think this is a challenge, and it's why we need to understand how this AI is thinking. So we need tools to sort of help it to articulate, well, why are you suggesting? What's your justification for that? And it's one of the things in the book I've tried to not. I've tried to lift the bonnet a little bit to explain how machine learning works. How does code change itself in the interaction with data? And I think it's trying to understand how AI is working is going to help us to make decisions about whether we should trust, incorporate, make it a good collaborator, or whether perhaps this is got strange biases that are beginning to appear that maybe we shouldn't trust this piece of AI. So a few more questions. Will AI be used in driverless cars? And if so, will it be safe? Well, I think that's really interesting, because that's another, obviously, one of the really key uses that perhaps AI will be making. Already I think there's evidence that it's safer than human drivers, but I think the challenge is here is that, of course, as soon as there's one death, and there was obviously news last week about how one of the drivers, or wasn't driving, was sitting in one of these driverless cars, who killed a woman, is now going to be tried for the death of this person on the road. I think that still the evidence is that these are actually safer than humans, but I think there are really interesting dilemmas here. I mean, there's kind of philosophy 101. If you've got a choice between killing the driver or killing 5 people on the road, what does the driverless car decide to do? Well, you bought this driverless car, you don't want to be sacrificed for, but on the other hand, the philosophical decision, presumably the AI would choose to sacrifice the driver. I've done a few events with Ian McEwan about his new book, Machines Like Us. And at the heart of that book is a moral dilemma, and the AI makes a very different decision to the one the humans would make. So yeah, I think very interesting to see, who should be responsible for the code. Again, here's, we're talking about the creativity of art. Is the code the creative one? But what about when a driverless car kills somebody? Who's responsible? The company, the code, the coder, the driver. So really interesting questions there. Could one AI develop a relationship with another AI? I think that's a really fascinating question, because it makes me think of one of my favorite AI films, actually, because some of you may have seen the film Her, where this guy, I think he splits out with his girlfriend or his wife, and he gets this piece of AI and as a kind of AI girlfriend substitute, then falls deeply in love with the AI. But halfway through the movie, the AI dumps the human and says, well, you humans are just so slow, and says, I enjoy being in the presence of other AI because I can get to know that AI much more quickly, and we can have a fast, deeper relationship. And I think we're already seeing that in the art that's being produced by the AI, because I think that the second piece of art that I showed you, those 4 pieces, there's a complexity that's beginning to emerge, which actually we humans are finding it a bit too complex. Also, the music it's producing, it's quite hard to listen to sometimes. And it's almost as if the AI is producing something that it finds sort of creative and interesting. Maybe another AI does, but maybe we're going to start to see AI creativity really is just creativity for another AI, rather than for a human whose kind of embodiment is kind of making that difficult. So a few more questions. Will AI kill human creativity? I really try to make this a positive book, because I think there's so much dystopic talk about AI, not just killing our human creativity, but killing the human species. Hollywood loves the kind of idea of AI being kind of wiping out our species. But actually, I think at the moment, this new AI that's emerging is not a competitor, it's a collaborator. And actually, I think that that's the exciting thing, that I think it might actually stimulate greater human creativity, not kill human creativity, that we, as I say, keep behaving rather like machines, and we need to be enriched. And I think I often translate AI not as artificial intelligence, but augmented or alternative intelligence. And what's fascinating is that AI is thinking and doing things differently, and that's exciting. We don't want to replicate the way we think already. So I think what we're seeing is that AI and human together can quite often do more than just the AI on its own or the human on its own. So at the moment, I think that that AI won't kill, but will actually stimulate human creativity. And let me say another thing. There was a really interesting story about storytelling that came up towards the end of the book. An AI that was trained on human stories and then had to tell its own story. Actually, stories I used to love as a kid. Maybe some of you remember these books where you get to choose the story. So turn to page 46 if you want to go into the attic, or 54 to go into the cellar. And so you got to choose the story. Actually, of course, we have a very modern example, Black Mirror, with the Bandersnatch episode. You got to choose the story. So the AI learned on human stories and then was asked to tell its own story by making choices. And the interesting thing is that by learning on our stories, the story it ended up telling was much more humane. It was more human than an AI which hadn't been trained on our stories, which actually told rather a dystopic, disturbing story. So I think there's something hopeful about this, which is, we want to create AI that is empathetic, that's on our side. And I think by using our world, it can actually, by learning that, perhaps produce an AI that is on our side. Okay, a little bit more time for some questions. Do you think we'll ever see AI like in Westworld? Yeah, that's interesting. I mean, that's a real kind of Turing testy AI, isn't it? Because this AI is so convincing in Westworld as sort of a human interaction. And again, in some ways, I think that's the boring side. I really want AI that's doing something kind of genuinely new and different. Of course, there's an extra bit of ingredient there, which is the robotics in Westworld. And I think actually sometimes the robotics can mask what's important about AI. I've seen some kind of AI artists which are sort of robots looking very human-like with sort of amazing faces, and the art it produces is really not very good, but we get taken in because we see something very human making the art, and it sort of convinces us that it's better art than it actually is. So it's interesting that Westworld is combining amazing AI but also with extraordinary robotics, but sometimes I think the robotics gets in the way of creating really interesting AI. Okay, perhaps time for one more question. Yeah, this is an interesting one. Actually, a lot of you voted for this one. Can AI creations ever be free of human bias? I think this is really important because we're seeing some very bad examples of AI making bad decisions because it's picked up data which has human bias in it. I actually did an event last year with a woman from MIT Media Lab. She's a roboticist, and she told me this story about how she had these robots delivered to her lab, and they had vision recognition software to interact with humans. And when she switched them on, they completely blanked her. And she's like, oh, maybe it's faulty. But when she got other people to come into the lab, the robots started interacting with them. And then she realized what the difference was. She was black and the other researchers were white. And when she lifted up the bonnet of how this AI vision recognition software was working, she realized that the AI had only been given white faces to learn from. And so she's now started something called the Algorithmic Justice League, which great name, which is basically, that we really need to make sure that the AI that we're producing isn't just replicating bad human bias. And curiously, in rather like the GANs, the generative adversarial networks, we can sometimes use AI to help us identify bias in data as much as the AI can sometimes replicate it. So using these GANs, we can sort of sometimes try and help stop that bias. But anyway, great, a lot of questions. That's all we've got time for. So I'm going to hand back over to Gravity Fields, and thank you so much for interacting in this rather exciting year of Gravity Fields. But hopefully we can have a real one again next year.
Thank you, Marcus. That was absolutely amazing. My mind is blown. Really, really, really brilliant. Such food for thought. It's not an area I know really anything about personally, but wow, I want to look into more of it now. I just want to find out more. And so there's some brilliant sci-fi films, and recognize some of those. You can see that the sort of human need to tell those the stories and take it to its subject, its nth degree. But actually, there's some beautiful little moments. And I think the thing I've taken away most from this evening is Ron's Ron shirt was just as bad as Ron himself. I shall always live by that, clearly. But thank you so much for that. And to anybody watching, please do think about the book. As Marcus says at the beginning, on the gravityfields.co.uk website, there's a link to get hold of the book, and that's a very recent publication, so we'd love you to do that. So there it is. This marks the end of our Gravity Fields online day. Really hope you've enjoyed, obviously, this evening's talk with Marcus, but also all the events today. And just a reminder that we have John Chase's Rapper's Guide to the Solar System is on for whole of the next week. Anytime in the next 7 days, you can click on that and enjoy that 40-minute presentation, which went so well earlier. We launched our South Stephen Creative Colour Challenge earlier. Again, that film is available. It's a little 2-minute explanation of a project we're going to be doing, encouraging as many people as possible, using the idea of the prism, that Newton's discovery. We want people to send in creative photos using a single colour, choosing one of 5 colors, but sending them, and that could be household items, or it could be faces, or something you see out on a walk. And then we're going to build those pictures up together to create 5 beautiful flags for the district, with each one of which from a distance will look like a textured colored flag, but when you get up close, you'll be able to see your own images shaped into prisms. So do please look out for that. And also Griffin Historical, who do Mark Griffin did the Newton in Lockdown stories that we have filmed in lockdown earlier this year, are all available on our YouTube site as well. So on behalf of South Stephen District Council, a huge thank you to everyone who's been involved today, to John Chase, Nadia and Lou, our artists doing the colour challenge, to Griffin Historical, and particularly our patrons, Val Gibson and Dallas Campbell, who've been huge supporters and followers of everything we do on the festival, and I think will continue to do so, which is great. To everyone behind the scenes who's made today possible, which there were a number. This is the first time we've done this, and we've learned a lot from it. We have machine learnt as we've gone on, and of course to the absolutely brilliant, wonderful Marcus de Sautoy. Thank you to Marcus, to everybody, and we will see you, if not before, in 2022. Stay safe. Thank you.